Okay, so hi everyone, and thank you so much for coming here today and instead of going for lunch. So my name is João Silva. I work at CERN. It's the European Organization for Nuclear Research back in Geneva, Switzerland. But today I'm not going to speak about particle accelerators or particle physics. I'm actually going to speak about using a library called JVM to create automated web tests to test your web applications, which is because at CERN, even though we are a particle physics laboratory, we have lots of web apps to manage all aspects of the organization. So all the, let's say, the business parts of running CERN as a business. So here's the outline of the talk. So in the next few slides, I'll give a quick introduction to what functional web testing is, what it's not, its challenges as well. And then I'll show you what JVM is, how awesome it is, and why everyone in here, if you're using web apps, why you should be using it to test your web applications, especially a legacy web application, which there are quite a lot of them at CERN. And in particular, and given that the time slot is short, I'll show you a small example of how you can use JVM to do a very particular type of testing, which is called smoke testing, which can be essentially used to prevent catastrophic failures from reaching your production server. And of course, at last, I'll show you how, once you have your automated web testing solution developed, how you can then go on and integrate it with your continuous integration server like Jenkins or Bamboo. All right, so let's get started. So with functional web testing, a bit of definition, so make sure we are on the same page for the remainder of the presentation. So functional testing, what does it mean, right? Functional is a very broad term, right? It can mean many different things. But within the scope of this presentation, what I mean by functional testing, it's the tester only knows or is only concerned about that certain inputs will result in certain outputs. So this is also known as black box testing, wherein you ignore the specifics or the interns of the underlying software component which is under tests. So you basically assert that providing certain inputs result in certain outputs. And this contrasts, of course, with white box testing, like unit testing, where you actually want to test the underlying parts of your software components. So that was functional testing, but when talking about automated functional web testing, what it usually means that you are programmatically controlling a web browser to simulate the actions of a user on a web page. So for example, a functional test on Google could be, for example, that by navigating the search engine page and by typing something in the input box and then clicking the search button, you will eventually be bounced back to results page with some list in there. So as you can see here, the underlying application logic, so all the page rank algorithm of Google, is not being tested in here. What we test is that basically we type something input, we get some results back. We don't really care what is done in the middle to get the results back. And of course, by doing this, you can test all application layers at the same time. And it's also language agnostic because it doesn't matter if you use COBOL in the backend, it doesn't matter if you use anything else, because you're testing just the front end. So you're testing, everything fully integrated through testing the UI. And why do you need functional web testing, right? Why not just unit testing? Well, because when developing for the web, unit testing only goes so far. Some web application errors, they typically come from a JavaScript error, which only happens in a particular version of a particular web browser. Very recently at CERN, we were developing a web application for managing some dashboards for the Beam instrumentation. And some parts in there, they were broken for IE 11, but only when running compatibility mode with IE 7 or 5. So these kind of things are very hard to test with unit tests. And it also doesn't help to identify client-side regressions. Or it could be that there were some breaking changes in the REST API consumed in the client side. And so unit testing doesn't really cover the bridge between the client and server side. That's why I need functional web testing. But unfortunately, the tools for executing and writing functional web tests, especially for the Java world, have been very, very cumbersome to use. But then JVM arrived and changed it all for the JVM world. As Obi-Wan would say, it's an elegant weapon for a more civilized age. And so now I'll provide you an introduction of what JVM is and an overview of how you can use it as a tool to do functional testing. So what is JVM, right? So JVM is a browser automation solution or framework as you wish, and it's used to programmatically drive your browser. What I mean drive, that's you actually instruct your browser like Firefox or Chrome or even a headless browser like PhantomJS, and you tell this browser to do things on your behalf. So you programmatically tell, click on the close button, click on the search button, etc. And why would you need this? Well, the main reason is for doing functional or web or acceptance or smoke testing. They're pretty much the same in any case. but also for scripting and screen scraping if you want to do it. The library is written in Groovy, a JVM language, and its current version is 0.13.1. So what's so great about JEB, right? Why am I talking about JEB here? Well, because JEB is a library which essentially took the best of all worlds and merged it all together in a single tool. So it uses all the power inherent in the Selenium WebDriver API without exposing the complexity to the end user. It also provides the elegance of JQuery content selection, the robustness of page object model, and the expressiveness of the Groovy programming language for JVM. I'll go now into each of every one of these items. So under the hood, as I said, JEB uses the Selenium WebDriver APIs, which doesn't need much introduction in the automation world. It's pretty much the de facto standard. It's even a W3C spec for doing test automation. And the idea is, again, is that you basically automate your browser to go to pages, do things on your behalf, and then report back to your program. It provides cross-browser support, so even for Microsoft Edge, the latest version, as well as mobile browsers and headless browsers such as PhantomJS. And this is a simple example of how you can use the Selenium WebDriver APIs, not JEB, to drive the Firefox browser to do a Google search for us. So what you see in there is we're telling the browser to open a Firefox driver. So this will basically take out your installed Firefox version. You will start it up, and then we'll go to google.com. And then we tell the WebDriver to go, okay, please fetch me the element name Q, which is pretty much the input box where you type your queries in Google. Then you send keys, so you type CERN, and then you submit the form. And then you assert, or you print in this case, that the title is something which you took out of the page. So as you can see here, the WebDriver API of Selenium is pretty much a nice API that allows you to select content, send keystrokes, navigate to pages, etc. It's just an API to drive your browser, to really make your browser work on your behalf. But not everything is that simple, right? Because this element submitted Google, of course, is not completely a postback. It's actually a synchronous call. And if you want to make this work with WebDriver API, you need to basically do polling. So you need to do this kind of long polling here, which you see, this WebDriver await. And the code just gets very complex. And if you keep using WebDriver, you'll find more and more corner cases, especially when you start working with Ajax, that it gets very troublesome to make all of this work and to code all of this. And yeah, that's why basically JEB came into play. So for example, even for finding elements, you never do driver find element by name Q. It's a nice sort of DSL, but it's not quite nice as jQuery, right? In jQuery, you just type $Q, and then you get the elements. So that's what JEB was trying to introduce here. So when you add the familiar and powerful jQuery content selection and Groovy's dynamic features, this is what you end up with for doing the exact same thing as you were doing before with WebDriver API for Java. So it's just so much simpler, right? It's just a pure DSL there. And what you do is, you find the element using this jQuery-like syntax. Then you can use even operator overloading of Groovy to send keystrokes to particular elements. So that element left shift CERN, this essentially just pushes the CERN string into the element which is referenced above by the input name Q. And then for doing long polling, of course, it still has to do long polling because it's an Ajax request, but it provides some nice closures for you, like the wait for, whereby everything which is inside a closure will be constantly checked up until a point where the wait for is concluded and you can advance in your tests. So even if you want to do more complex content selection, you pretty much have all the jQuery API on the server with JEB. So it's much nicer, and if you want to try to do these things with the WebDriver API, it's very, very troublesome to do. And of course, with less code comes responsibility, so JEB really is a really nice library. But so far, the examples I've given to you with going to Google and typing things, it's more about screen scraping than actually testing. So you're just going to a page, typing something, getting something out, extracting data from a web page. And what we want to do here is actually test these things. So how do you do functional testing with JEB? Well, JEB by itself doesn't really provide any testing functionality, but it integrates with any test framework you'd like. So you can integrate with JUnit, Spec, TestNG, and even Cucumber. So you can have really, pretty much English-like phrases for doing the tests. And in more examples, I'll use a Spec framework because I could quite like this approach, and I think it mixes very well with JEB, this spec-oriented approach. So to exemplify the test, I'll be using the CERN single sign-on page. It doesn't have, it's not rocket science. It's just a login page. It has a an input for the username, for the password, a sign-in button, and then there's an error message if something is wrong. And what we want to test here is that if I submit a wrong username or a wrong password, then I should get an error message which is showed in there. So let's see how this looks like with JVM. So this is a spec, right? It reads pretty much like English. So you define a method called should redisplay from form with an error when password is bad. And then you can really see the whole thing really like English. You say, when I go to login.cern.ch, then you assert that you're actually there because there could be some error on the server and the page is not there. So you assert that the site name is actually CERN single sign-on. And then you say that when I fill up the username with the correct value and the password field with the wrong value, and I click the login button, then I should still stay at the same page. So the site name should still be the same, but then the label with the errors should now equal to my invalid username or password label. So out of the box, when you run this test, you get screenshots of the page, the HTML which was rendered by the browser, etc. All of these out of the box with JVM. Any questions so far? All right. There's a problem with that spec I just showed you because the problem of writing tests against the web page is that, of course, we need to refer to elements within that page in order to click links and determine what's in there, what's displayed, what's not. So you're basically coupling your HTML structure to your tests, which is a bad thing to do. But of course, JVM supports this pattern called the page objects, which is essentially a pattern which wraps or encapsulates an HTML page, allowing you to manipulate elements without digging around in the HTML and therefore reducing coupling. It sort of creates a content model around an HTML page. So let's see how this works out for the previous example. Right? Let's get some page objects. So as you can see here, we have the login page, right? So we need to create an abstraction for all of this. So this is the way you do it with JVM. You create a class, login page, which extends JVM's default page. And then you have to say where the page is, so you define the URL. Then you define @ block. And @ is a closure, which is essentially an assertion to let JVM know that if you are on the page or not. So in this case, I know that I'm on a page if there's an element called site name, which is equals to CERN single sign-on. And then you define a block with all the content you want to manipulate. So you call, for example, username to the box called txt form login. The sign-in button is called vtn forms login, etc. And then you can even put methods in here which manipulate all of this. So let's now rewrite our spec using this page. And voila, this is how it looks like. It's much nicer, it's like almost like poetry. And if you compare this to the old test, right? So in here, you just say go to login page. And before you were saying go to hard code URL in there. Instead of assigning values through directly referencing HTML IDs in your test, what you do here is you just call login method, which essentially assigns values to the underlying 4 elements. But it's all very nicely encapsulated in this object page. So really, your test, if the HTML page changes, if somehow the label called error message is now changed to, I don't know, my new error message, this would still work because you just need to change the underlying page element. Your spec will be exactly the same as it was before. So yeah, much nicer, right? And when you run this test by extending this JVM reporting spec, by default, JVM provides you reports of what happened. And this includes all the HTML which was rendered to the browser. So a screenshot, in fact, of what the browser has visited, and the HTML which was sent. And this is not just the HTML which was sent in the response. This is actually the HTML which was processed after all the JavaScript code was loaded by your browser. So after all the JavaScript was processed, after the document is ready, after the DOM is ready, this is what shows up in his HTML result in there. And this is done for every page you visit throughout your tests. So that was a very quick introduction to JVM. I mean, it has many, many more features, but it's very hard to fit them all in this 20 minutes talk. But if you're interested, of course, please go and read the book of JVM. It's kind of like the Bible for this library, and it's official documentation. And now I'll briefly show you how we, at CERN, and one of the applications I've been working on is called EDH. We've been using JVM to do smoke testing to make sure we don't deploy catastrophic failures to our mission-critical application. So in this case, it's called EDH, electronic document handling. This is, let's say, the most used application at CERN is application which covers more than 60 official procedures. So from safety, turning on fire alarms, disabling fire alarms, from procurement, so buying things, buying cables, buying FPGAs, finance procedures, HR, so hiring, firing, retiring, all those procedures in there, they're all embedded in this application. There's a document type for each of these applications. So we have over 1 million lines of code, so it's quite an old application. And as you can imagine, it's quite hard to maintain this beast of so many lines of code, Java code. And sometimes we just screw up as well, right? So we are deploying releases which include bugs like these, where you cannot open a page because it just completely throws an exception to your face. And we'd like to prevent this. And before, what we used to do is it's kind of embarrassing, but I'm sure, some of you have used it at one point. Once you deploy, you go through there and you test with different browsers or with different pages. And you click in there and you see, if this works or not. You go click on buttons, you try to simulate some functions and see if it more or less looks okay. And this is exactly the kind of automation that Jeb excels at. So the first things first. So we test if the login works, right? If the integration with CERN single sign-on works for our application, and this is our base specification. So it kind of looks like this. So it basically says that I should be redirected to the login page and then brought back when I try to access an application for the first time before being logged in. And you say, basically, it's pretty much English the code. When I go via the desktop page, so it's my main entry point of the application, then I get bounced back to the login page. And then after I log in, I should be brought back to the desktop page. So this basically ensures that all the integration with CERN single sign-on actually works fine. And then for doing the smoke testing part, we pretty much do a crawler which goes through every link, so every possible document type, all the safety procedures I mentioned before. We go through all of them, and we have some tests to make sure that they can actually be opened, and you can actually do things with them. And so that's for the creation of new documents. For the random documents, what we do is we use the search functionality of the application, and we go through random documents and try to open them and use the same assertions as before to make sure we didn't break any document once we deploy to our pre-production environment. So this was it, right? This was a very small development which basically avoided having one developer or two developers spending half an hour after each deploy to try to click randomly and see if everything works fine. So this is something which we're ready to do, and it's particularly useful if you have legacy applications as the ones I was working with before, where it's particularly hard to refactor the code and all those things to make sure it's testable. And with these, since it's a web application, we can more or less be sure that things are working as expected. So at last, I'll show you how you can then integrate all these tests with your build system. Because once you have the solution deployed, you have to make sure that you actually run it and it's integrated to your build system, that once you deploy to pre-production, you actually run these tests and make sure they're green before deploying to production. So how to integrate with CI tools, right? It's very easy because Jeb actually produces JUnit test results in XML format. And most CI tools, at least Jenkins and Bamboo, which we use at CERN, you can just create a test which reads an XML file from JUnit and just checks if it's green or red, depending if there's failures or not in the XML file from JUnit. So it's very straightforward. The problem is that if you want to run tests headlessly on a continuous integration server, you'll quickly realize that there's no head in this server, right? So there's no display output for launching a browser, because as I said before, when you say you drive your browser, you actually literally open up your browser and make it do things for you. But of course, when you're on a headless machine, a headless terminal, you cannot do that. So what can you do to solve this problem? Well, the solution is to use a headless browser, such as PhantomJS, which is based on WebKit, and basically do everything for you without having to have a graphical display. This is actually what we use at CERN. It was the easiest one to configure, and it's the one we've been using for the past year. An alternative is to use a virtual frame buffer. So if you're using the X server, you can use XVFP. And the idea is that you launch the browser virtually, and then you sort of emulate a graphical display to put what the browser would display in the real screen. And finally, you have remote browsers, so you can actually put a Selenium server somewhere and make your tests run in that machine. There are several products which can do this. One of them is Sauce Labs. And this, for example, you can test pretty much every version of IE, and you can send your tests there to be run in every browser in there, and then get back the results to your integration server. So this kind of wraps it up. So in conclusion, automated web testing provides a way for you to be sure that your web application is doing the right thing without you having to change your underlying application to be more testable, let's say. And as you saw in our application, and given the different amounts of architecture that we put in place for several years, for 20 years in fact, it was very difficult for us to implement unit tests for this. So when this was an insurance we have that when doing a release, we're not breaking the big part of the application. And this, of course, was made easy by Jeb, because in conjunction with Spec and the jQuery-like content selection, it allows you to very quickly develop this very full suite of tests to have in your application. And of course, having tests and not running them is not useful, so Java is also integrating very easily with CI tools, such as Bamboo, as I showed you before. Here are some references you can find very easy. Search for Java and Groovy. And yeah, that kind of is it. Thank you very much for your attention.